So what can you tell me about how important the work is that you do with modeling, and where is modeling heading? Are we really in a rapid phase of model improvements? And what happens with you know your leaving?
Yeah, so I mean, we've seen a lot of improvement. If you look over the last 10 to 15 years, there's been huge improvements. Track forecasts for hurricanes have been improving in 30 years, but really over the last 10 years or so, we've seen intensity finally start to improve, and that wasn't the case for a long time. And like I said, we're working on structure now and rapid intensification and all these things that we really didn't think was or weren't sure was possible a decade ago. But because of the increased computer power and the expertise of folks that, my colleagues and that I've been part of, we've been able to make a lot of advancements in the model's physical approximations and the grid spacing, the resolution to get those fine scale details. So I think we're in an exciting time. As artificial intelligence becomes more prevalent. One of the things I was starting to do in my role at EMC was sort of help compile sort of a list of everything that our group was working on AI related and sort of write a roadmap to chart not just for hurricanes, but for all sorts of weather, what our plan was going forward. And, I think the weather enterprise is changing, but there's a lot of technology that can make it great and even better. And, I'm hoping that what's happened to me and so many others isn't too disruptive of that, but it could be.
Yeah, and your mention of AI is really important because I know that that's an area of expanded and accelerated research within NOAA. And questions that I get when I go around and give talks sometimes is, why do we need all those other models when we now have AI that runs so fast and so, higher resolution and things like that? Can you enlighten us, Andy, a little bit about the direction that AI is taking and whether or not those physics-based models are necessary anymore?
That's a really good question, and that's something that we've been studying. And I think certainly for things like large scale synoptic weather, I think AI is getting to a point where it's already pretty skillful. Like the maybe the 10-day jet stream type of forecast, and we've seen that with some of what the European centers worked on with their AI model and the GFS GraphCast, things like that. But things like hurricanes are tougher because they're extreme events. And so, AI really, it's only as good as the data that you have to train it. So, kind of a garbage in, garbage out, which is true for all models. And so, that's one of the things for hurricanes we're really talking about is, we don't have a training data set to do that kind of AI thing. So, we're gonna need, that's something we're talking about building. And, that's probably, a decade or so off from being, completed because, of all the data and just how intensive it'll be to build that. And, it'll be a great tool, but I think, certainly in the short term, we're going to need both, and I think having experts that in both of those things and, people that are sort of hungry to learn and learn how to apply both of these will be really critical.
Yeah, so I've been thinking that it's critical to have that foundational model set from the physics-based models to continue to train AI. Do you think that we'll ever get to the point where we don't need any of that and we can just use AI?
I don't know. I don't, it's hard for me to speculate 20, 30 years down the road. For hurricanes, I'm kind of skeptical that we'll ever get to where we completely lose the physics just because of how complex they are and how extreme they are. But I think AI is definitely as techniques are enhanced and things like that. I think it's going to be a bigger and bigger player. One thing I think that we'll see more of is the use of AI to do these what's so-called ensembles. Where you have a bunch of different versions of the same model, and you can sort of get an idea of like uncertainty and percentages. I know people like to think in those terms, and AI allows you to do that fast. So I think it'll be a great tool, and if used correctly.
Yeah. Back to the modeling at EMC. How many scientists are working at EMC, and do you know how many have been let go?
There were I think about 12 of us probationary. So that was about a quarter of the federal staff. There's also quite a few contractors. But a quarter of a federal staff is a big deal. And that was, people that ranged from, what I'm doing hurricane stuff, with HAFS and GFS and things like that. But we had people working on, like the model verification software to validate it. People work on the computer architecture, severe weather modeling, all sorts of things, ocean modeling. And the other thing I think it's important for people to understand is, that the probationary employees, which has kind of been the focus of the firing so far. Most of us worked for NOAA on like the contract or university side for 5, 10, some people as many as like 15 years. So we actually have a lot of expertise in the organization. And for most of us, become a federal employee was a promotion. So, that's a lot of young talent and talent that's also experienced that's being lost with this.
Yeah, for sure. I mean, those probationary employees, I've heard so many, just even getting working for NOAA and getting a promotion to a director or something else, that enters the probationary period as well. So, like you said, they may have worked there for, a decade or two, gotten a promotion, become a probationary employee, and then get fired.
Yeah, it's happened. I've had several colleagues kind of with similar stories and, veterans, like I said, people that have served our country in many ways and have these great, all sorts of amazing experience. And, unfortunately, none of it seemed to matter so far.
So tell me, Andy, and you're an expert modeler. We all know that models take input, and we want that input to be as accurate as possible and as high resolution as possible. What would be the impact if certain observations, whether they're surface observations, ocean observations, satellite observations, what happens to modeling if they disappear?
They become more inaccurate because garbage in, garbage out is the saying. And that's already one of the toughest things for our modeling is to the data assimilation, that getting that data and getting things right at the start, because your physics can be perfect, but if your initial state is garbage, it's gonna, the whole forecast is gonna be bad, and whether you're doing AI or traditional approaches. And so losing or degrading satellite data or radar data, that just won't, aircraft, all this stuff. I mean, that'll obviously have negative impacts in the short term, for when a weather event's happening, but also in the forecast. And I've seen things like, offices have already had to, reduce the number of balloon launches in some places, and there are places, in the southeast that have, there's large gaps. And I saw something about one of the stations in Alaska may have to, reduce or eliminate their balloon launches, which means we may not get as much data for storms entering North America, and
Yeah.
that's a big deal. And it's across.
Yeah, I think that's the Kotzebue station. They had to stop the release of balloons, and so let me just place this question on you. I mean, because some people may say, well, it's one balloon, so what? What does that mean to you when you hear that a observation point profile of the atmosphere is going to disappear?
Yeah, it's really the location, because one of the over Alaska, and that's typically where a lot of the jet stream impulses that affect a lot of our weather over North America come in is through from the northwest there, across the Rockies. So we already have a lot of, that's often a lot when we see a lot of our sort of uncertainty and forecasts is when that process is happening. And so losing even more data there, in what's already kind of a data sparse region because it's so it's sparsely populated, that's going to just make our forecasts even tougher.
So it could introduce errors, I guess, right? If there's no data there where you used to have data, then the model's going to make it, right?
Right, it's going to it's going to do its best to fill it in with the gaps and approximations, and but it won't be as good, and that's true for that one observation point, and the more of this that happens, the worse it's going to get.
Okay, let's take a step from a one balloon going away to ocean buoys going out and not being maintained, and we don't have ocean observations anymore. What difference does that make?
Well, that's a lot of things. I mean, obviously, for hurricanes, we use the buoys. You occasionally get lucky enough where a hurricane gets close to one of those, but even if a hurricane's not close, that gives us information about the waves, which I know, a lot of people, in the fishing or cruise industry are interested in, and have a lot anybody with any kind of maritime interests. But even things like the buoys, the tow array out in the Pacific that tells us about El Nino and La Nina. That has huge climate implications, because if we know that an El Nino or La Nina is developing, that sort of informs what we can expect in terms of rain and temperatures across the U.S. for that the coming winter and or spring, and that has big implications for agriculture and I'm sure skiing and just all sorts of things. So this data, it has so many downstream impacts that on commerce and on people's lives that I don't think people realize all the time.
Yeah, and I have been thinking and have heard recently that some of the leases on some of the federal buildings are going to be terminated. And I guess without further information, you just have to assume, does that mean that the federal workers in that building have to vacate and close? Or does that just mean the lease is terminated and they have to figure out some other term for the lease to stay there? But if they terminate the lease for NSEP, and NSEP has to close and vacate, what kind of impact do you think that will have globally and nationally on weather prediction?
Yeah, it's hard to say for sure without knowing details of the plan about where they would move it or things like that. But just on a surface level, it seems really, really dangerous because yeah, INSEP is the agency I worked for was based out of there, and they basically run all of these models, and they're the core of developing it. So I mean, any US based model that you use, whether it's the HER or the NAM for severe weather, whether it's the GFS and for global weather, and or the hurricane models that we use, all of that comes out of there. So any person, whether it be a private meteorologist, a TV meteorologist, a weather app, anything that uses that data could be jeopardized with a move like that. And like I said, that was just reported yesterday. Hopefully as details come out, maybe it's not quite as bad as it seems at an initial look, but that move strikes me as potentially quite dangerous.
Yeah, and I just want to take one other step because I'm actually unsure of this. I have a couple of emails out to some others that used to work at NOAA that I'm hoping can help answer this question, but maybe you can as well. If NOAA modeling takes a hit, let's just say that NOAA stops issuing model forecasts. How would that impact the aviation industry?
Yeah, that's a good question. I'm not directly involved with the aviation industry, so I don't know, exactly what data they use, but I know, the Weather Service puts out their aviation products that are widely used, and I know, the modeling data, like the GFS and all of that's pretty widely used. I know people use this isn't aviation, but like the wave forecast from GFS, for some of the
Mhm.
boat stuff. So I think there's a lot of people that use this data that maybe don't even realize that it's coming from the GFS, because the way a lot of these times these products work is the modeling data comes down, it's filtered through your app or some kind of post processing, and then you get your final product, but you maybe don't even realize the source of that product was this global model output initially. And that's one of the cool things about the US model is we've for so long we made this data basically freely available to the taxpayer for what's I think if you look at the numbers, the cost for all of NOAA, not just the Weather Service, but all of NOAA, including the satellites, the models, everything, is about $20 per person per year. And for that, for the cost of going out to lunch, you get all this data, at your fingertips, and you can do whatever you want with it. And so, I think losing that ability would be a major, major blow.
What do you think the impact having the cutbacks now have on any aspect of hurricane forecasting, whether it's flying the planes, gathering data, or issuing those forecasts to the public and decision makers?
I think I know the folks that I work with are they're going to really work hard to keep putting out great information, but it's not realistic to say that this won't have an impact, because right now we're in the middle of the development cycle when we sort of build our new version of the model that we'll put out for operations this year. So with losing people and all the uncertainty during that process, the upgrades may not be as good, so that we may not see the continued improvement that we did. And if things get bad enough, we could even see degradation. With like the flights, I know the Aircraft Operations Center in Lakeland that
Mhm.
do this. They lost a couple of people, like flight directors, the meteorologists that basically work with the pilots to make sure that they're flying through the storm safely while also collecting the data and fulfilling the scientific mission. Like I said, these people were, military, former military usually, um, and so, losing that scientific expertise and is gonna, we could see missions that are not as reliable and things like that, and that could be a big problem.